Good morning. I'm Akash Reshan, 17 BEC 1065, and I'm here to present my robotics third digital assignment. I'm going to be talking about two softwares. The first one is RoboDK, and the second one is ROS. So, the first software I'm going to be talking about is RoboDK. RoboDK is a very simple but powerful software that can be used for robot designing. One of the most important features of RoboDK is that you can forget about CAD. We don't need to design robots as such before interfacing them or coding on them, because there are already hundreds of libraries available in RoboDK itself with various robots and various weights and various functionalities of robots already available on RoboDK. So it is very simple, and it is not even heavy on your laptop. So so Robotica is a open source software. It's freeware, so we can work on it very hassle freely. There are a variety of libraries available. Starting, we can do anything we want with these robots, from painting to grilling a wall to welding to milling, etc., etc. So, the process on how we code on Robotica is very simple. So first we choose the robot which we want to use. After that, we choose a reference frame for the robot. After that, we choose the tools that the robot should have. So, for instance, if you wanted to drill, we need to give it a drilling machine. If you want it to be a for milling, we need to give it a plow, etc., etc. So we give them the tools. After this, we give them the targets, like what they have to do. For instance, if it's a painter, we need to give it a wall where it will paint, and we can also give it objects. So for instance, if you are the miller, we need to keep the crops in a bucket. So we can create a bucket so that the robot can keep the crops in the bucket. So after creating all of this, then comes the programming. The programming is very simple. All we need to worry about is the translational and kinematics of the robot. And just using our concepts of theory which we have been taught, we can easily code in RoboDK and generate lot of robots. Yet another huge advantage of RoboDK is that it's an offline coding environment. So basically, if we code in this, it we can directly code the robot using RoboDK. This reduce costs in a lot of way, because we don't need to first debug it over here, then go keep burn it into the robot again and execute in the robot. It's a hassle-free simultaneous process and saving a lot of money and time. So as you can see, there are a lot of the robot types, and even for each type, there are many types of weights and various other things, like many types of materials. So I'm pretty sure that we don't need to use CAD to generate anything, and most of our needs will already be there in the library itself. However, if we want to generate something to CAD, we can, and there are plugins through which we can interface that generated object to RoboDK. Another very interesting thing about RoboDK is that it is a very nice software for viewing a thing and checking out it, because there's a VR plugin, so we can see all the nooks and crannies of the robot from every angle and debug it easily. And it has many assistive technologies as well. One of them is the collision detection. In Simulink, we need to create a huge block diagram and have a lot of functions just for it to evade obstacles in its path. However, in RoboDK, it happens in a click of a button. There's just a checkbox which we just need to check. Once we do that, the collision detection will activate, and it will automatically evade obstacles present in it. So this is all about RoboDK. This is a very simple software, and we can learn it within 1 or 2 hours max. All we need to know is the theory behind on how to code the translational and kinematic mechanics. So the next thing I'm going to be talking about is the ROS. This is a very revolutionary software for the robotics industry, because this is the software that basically acts like the operating system for the OS, like how we have Windows for our laptops and Android for our phones. This is the OS for the robots, and it's the most popular OS. So why is this OS this popular? So it's not technically a operating system. It's been built on Ubuntu, so we can call it an operating system. It has all the functions that an operating system has, like hardware abstraction, low level functionality, message passing, etc. The main functionality though is the hardware abstraction. So basically, this ROS abstracts the hardware. That is, the coder from the top level doesn't need to worry about what is happening down. And this has been revolutionary because many people don't code in the robotic industry, because though they may be very good at coding, because of the hardware, it's very tough for them to debug errors, as the errors can be from the hardware side as well, and hence people are repulsive towards the robotics industry for coding. However, once the OS has come, it's very easy. So basically, now they can just code normally, like how they code for other softwares, and the ROS will take care of the backend. Like it has various functions, processes, and commands through which it can easily get information from the sensors or the GPS module or any module present in the hardware, and securely uh, give it to the programmer. So this is this is the main advantage of ROS. How do you develop in ROS? So ROS is basically an operating system. So we need an API to develop on it. So the API we use is called the ROS Py, that is ROS for Python. So what does this ROS on Python do? It basically, it's like it has all functions like print, display, etc., like all the basic functions. However, it takes into account all the background processes that the robotic hardware is going through, and ensures that that doesn't get affected by the software, and also interfaces it in a very effective way. So yeah, for yeah so sorry yeah so as I told you, it's very advantageous. So the another thing about the ROS is that it has seamless 3D scaping. That is, we can easily see the robots in a very effective way, and this is very advantageous while coding as well. ROS is like the next generation, and because of this, there can be huge developments in the robotics industry, because most robotic engineers are good at the hardware but not so great in the software. Because of ROS, proper developers who are very good at the software can come into this industry and create new and wonderful robots for us. Thank you. This is the end of my presentation.